good morning, good evening, and good night to all. Yeah. So I think I will start my introduction. So my name is Arun Magesh. So I work as a security researcher with Fire 2 Technologies. So I'm based out of India. So this time I'm going to go a little focus a little bit in depth on one single technology. So this time I'm going to talk a bit on Bluetooth Low Energy. So Bluetooth Low Energy, the basic Bluetooth, which at least like for the past 3-4 years we are using it. So before that we are using Bluetooth Classic and then your normal IRDA, your old phones. Yeah. So let's go to the slides. So about me, so I'm Arun Magesh, as I told you earlier. So I'm also a Intel software innovator. So I primarily, my full-time job is a security researcher at Fire 2. I'm also a 25 anniversary, and I also work on hardware. I'm also a maker where I build hardware devices. Yeah. So let me give a list on my company, Fire 2. So Fire 2 is completely into security. So we deal with all kind of security from your mobile, cloud, IoT, ICS, even card hacking. So we do all kind of conference stuff. Yeah. So agenda. So what we are going to talk about today is like a bit of introduction on Bluetooth Low Energy, how exactly it works. So what exactly is the huge difference between your previous Bluetooth Classic and your recent version of your Bluetooth Low Energy. And we will also go a little bit on the previous case studies on Bluetooth security, like your previous exploits, like the devices that has been hacked in the past. So we will do a little bit of touch on that. And then the third would be your Bluetooth security. So I'll do a little bit brief on how your works. So what are the different mechanism, encryption, how your device is being really secure. And then the fourth would be your, how do you really access your Bluetooth devices? So right now you have a Bluetooth device and your mobile phone. How do you really communicate with the Bluetooth device? So the last exploiting it. So how do you use all to really exploit any smart devices, such as smartwatch or smart, any kind of smart medical devices, healthcare devices. Yeah. So now let's go to Bluetooth Low Energy. I think most people would know exactly what Bluetooth is. So Bluetooth is basically a wireless communication protocol, which you will see it in almost all smart devices. I think I haven't seen any phone which doesn't have a Bluetooth. So Bluetooth is like pretty much the most popular commercial protocol. Even Bluetooth is still used in industrial level, but still the number of users using Bluetooth is more in the commercial sector. Yeah. So why do people really use Bluetooth Low Energy? So as the name itself says, it's going to use low power and also low resource for its operation. And if you compare Bluetooth Classic and Low Energy, both are completely different. So even if you look at it from a protocol wise, so entire operation is completely different from your previous Bluetooth Classic. And the reason why people are choosing Bluetooth Low Energy is because since it's low power, so you can have a beacon that can last for around six months to several years. Or if you have a device where it's just a solar harvester or some other thermal harvester, where you don't really need to worry about the device. So it can act as a beacon and then it charges automatically. And the good thing about BLE is almost all your devices have Bluetooth. So it becomes easy for devices to interact with it. Let's say you have multiple beacons implanted in your industry and then you want to really access it. You can use your traditional commercial mobile phone to access it. So it gives you more interoperability. Yeah. So specification, so again, it's low latency. So the communication is a little quick. The reason is also because the resource is also being reduced. Even the packet size has been reduced. So your data can be easily transmitted compared to your previous Bluetooth Classic. And even if you look at the power consumption level, so it only consumes only 15 milliamps for transmission. So let's say you have a device. So that is going to only broadcast once in 5 minutes. So then you can calculate your battery timing cycle based on number of times your device sends. And also you do have a lot of security in it. So they use a encryption called AES encryption. And then they use like, it's also similar to Wi-Fi. So if you look at your MAC address of your laptop or your mobile phone, the MAC address between your Wi-Fi and your Bluetooth is just one number next to it. So both uses the same frequency spectrum. And then, so if you look at adaptive frequency hopping is basically for every data transmission, the frequency hops. So let's say in your Wi-Fi settings, you might see like channel 11, 12, 13. So in this case, similarly, Bluetooth has multiple channels, like 32 channels, where if you start a connection request, so the data jumps between different channels, and then you get the data back. So now let's give a little bit introduction on like completely basics. So I think if you consider any protocol, understanding the protocol stack is the hardest part. But even in this case, it's super hard. So if you look at the Bluetooth 4.0 specifications, it's around 2,000 pages. So it's a little complicated if you go in depth. So in this protocol, you can see the controller. So this is basically your hardware part. So your physical layer, your link layer will take care of how your modulation works, how you communicate your data to a wireless. So how your hopping has to be there, what is the hopping increment you have to have. So what you do if there's a collision. So this hardware is basically, this block takes care of all those work. And then your HCI is basically the interface. Let's say you use a normal CSR dongle, so it's a USB interface. And then there are I2C based interface. There are SPI based interfaces, and there are multiple. Yeah. So this is where your device or your end device will take care. So L2CAP, it's basically L2CAP means logical link control and adaptation protocol. So what happens in this level is, so whatever the data you want to put inside, so this layer takes care of how your protocol has to be framed. So what is your first three? So is it your PTO? So where exactly your MAC should be? So this defines your message format of your entire BLE. And then security manager, that takes care of your encryption or how your pairing really works, how your bonding should work. And then if you look at these three stack, so general access profile, that's your gap, general attribute profile, that will be your GAT, and then your attribute profile. So these three deals with your data. Let's say you have a sensor that is going to give you input. So how do you manage these data? So that is being taken care by this. And then your application will directly interact with these layer and then get or fetch your data. Yeah. So we now give a little like very super basics on how BLE stack really works. So now let's go back and what are the possible attacks people have performed on BLE devices. Yeah. So this is recently, like 2-3 weeks back, a researcher hacked into a sex toy. So imagine hacking into a sex toy as a more privacy concern than hacking into your computer, because the data which you get from there is super critical where you can't compromise on that. So there are ways. So problem with these toys or sex toys is, so even if your Bluetooth has a security mechanism, so developer fails to implement it, because developers, based on my interaction with developers, so developers are not really doing everything from scratch. So they are taking resources from their reference design or examples where they write everything out of it. So which makes it a little unsecure, because even there are encryption in your BLE, but still people fail to implement it. Yeah. So second is smart lock. So if you look at most of your smart locks, so people are going to smart locks, smart infrastructure where everything they wanted to be connected. But imagine if your smart lock can be hacked into it. So there are tools like Gattaker, BTLE Juice. So they are more like your man in the middle of the tool. So where if you are trying to unlock a smart lock, where you can see the data that's being transmitted to the smart lock, and then you can reverse engineer the pattern, and then you can use your laptop or your mobile phone to do a replay attack, and then you can unlock it. You don't really need to know the basic password or anything that needs to unlock the locks. Yeah. So even this is like most recently happened incident where Segway are coming up with their Bluetooth connected Unicycles. So that also a problem where they haven't really implemented a security. They haven't implemented any pairing mechanisms. So it becomes trivial for anyone who have access to a normal Bluetooth dongle. They can directly go and interact with it, and then they can take over your device. So this becomes obvious. So it's also a light bulb. So if you will consider IoT hacking a light bulb is always the first step of getting into IoT. So there's a light bulb called as Magic Blue, where you can reverse engineer the packets, or you can reverse engineer your mobile application, and there you can understand what exactly the data is being sent to your light bulb. So you can really take over it without even having an app, or any intruder can really communicate with it. So right now, so far we have talked a bit on basically how a Bluetooth is, what exactly Bluetooth low energy is, and what are the possible attack vectors or attacks that has been performed. I mean, different devices where your attack is performed. So now let's talk a bit on how security really works in all those Bluetooth low energy devices. Yeah. So if you look at any Bluetooth LE, all your security and everything happens in your GAT and CAP layer, basically above your security manager. So everything happens there. So your security consists of 3 different blocks. So first one is your connecting. So basically you connect to a device. So the best example for this is, so you have a beacon, so you just connect to it. So your device won't really ask for a confirmation that, okay, this is a valid device or not. So you just connect to it, and then it can directly connect. Yeah, the second step is pairing. So if you look at few devices where, like say, few smartwatch, so it will ask for a question. Let's say, okay, our device is trying to access your device. So can you pair it, yes or no, or a numerical key or something? So that is where. So what happens is, during the pairing mechanism, your key has been exchanged. So if you look at L2CAP is more like your network layer where you can really encrypt it. So what happens is, in the pairing, so if you do that, so your device will say, okay, fine, for this encryption, this set of key is needed. So if someone else tries to access it, they still need the key to understand the communication. Yeah. So bonding is your next process of pairing, as I told you earlier. So once your encryption key, everything is being set in the device, for the next transmission, again, you're trying to connect to the device. So your device will have all the exchange keys. So it will directly establish the encryption connection, and then where it doesn't really need to exchange any keys for it to work. Yeah. So exactly this is where the entire problem relies. So if you look at the pairing, so for pairing, you need to have a acknowledgement unit in your end device, let's say a button or a display or any sort of input device to enter whether you're doing a good pairing mechanism or not. But if you look at a typical light bulb or any other beacon, where you can't really keep a switch or a display where you can really put it. So that's where security sort of fails in these kind of devices, where it just works till connecting. So it just connects to the device, and then you can just access all the data from the device. So this is how a connection works. So basically your device is your broadcaster. So it will send advertisement packets. It will basically broadcast its MAC address, UIDs, and basic informations out. So where your observer is your mobile phone. So if you look at your Bluetooth application, where you can really scan for devices. So basically during scanning, so your device will capture all these advertisement packet and then displays you. So when you press your connect button, so it will send a connection request, and then it goes to your GAT server, and then you communicate the data. If there's a pairing, another block, it will encryption, and then your data starts. Yeah. Now let's talk on the pairing methods. So there are like around 4 methods of pairing. So first one is your just works. So during your pairing, if there's no button, still you can enable whatever the communication above your L2CAP, you can still encrypt it using your AES, and then you can transmit it. Second technique is your yes or no, like your smartwatch. So if you're connecting to your smartwatch, you get an option notification, okay, when this device is trying to connect it, do you want yes, tap to yes or no? So that is one method. And third is your passkey, where your end device and your main central device will ask for a passkey to type in individual devices, and then you get paired. So out of band pairing is more like instead of using a normal keying mechanism, so you can use NFCs, you can use QR code. So if you look at your Apple iWatch, so you have a QR code to pairing. So that is basically your out of band. Pairing. Yeah, so the problem here is, so in case of your JustWorks, so JustWorks, the key will be 000. So the problem is any device can connect to it. So since there's no any physical authorization, so if a developer have really implemented JustWorks, you can still reverse engineer it. There are tools like Uber tools where it will capture all the packets your L2 cap, and then you can still reverse engineer the keys, and then you can again decrypt it, and then you can find the patterns as in the data that's being transmitted, and then you can replay it in your the GAT profile, and then you take over the device. Yeah. So this is exactly the key mechanism which I have found. Yeah. So what happens is, so in this case, I have told you this is basically your key. So numerical comparison will also have a sort of like a key, and here also, it's, if you look at everything is like 6 bytes. So what happens is, so during your both of your devices will, so let's say you are using JustWorks, so your device will send like 6 zeros, and then so they will create a key, something called a short-term key. So that is basically a combination of 2 random numbers and also your TK, that's your whatever the key that you entered in the normal pairing mechanism. So this key is being generated. This key is used to generate another key called as long-term key. So that is the main key that encrypts all your future communications. So LTK will be saved in both of the devices. So whenever a bonding process finishes, so if you again reconnect to the device, where you don't really need to exchange STK every single time to encrypt your communication. So both have LTKs, so your encryption starts automatically. Yeah, so the thing is, this is also a vulnerable. So the thing is, your first SDK is being transmitted once. So if an attacker tries to sniff those communication, he can still reverse engineer and then find your long-term key, and then he can reverse engineer it. There are tools which uses OpenTooth1 and a tool called as Crackle. So which just captures all your raw RF and then converts into a BLE packets and then looks for all the keys. If it's TK, what kind of TK they use, how do you reverse engineer it, even random number is being transmitted. So that can also be used to reverse engineer and then get your LTK and your STKs. Yeah. So how do you interact with LE device? So if you want to really interact with it, so the basic trade-off tool is your normal Bluetooth 4.0 dongle. So if your laptop has an inbuilt 4.0, that's great. And there's a tool called as OpenTooth1. So that is basically your Bluetooth ISM sniffer. So your CSR works above your L2 cap layer where you can read and write inside your GAT. Whereas your OpenTooth1, which sniffs entire communication from your L2 cap. So basically everything that has to deal with your security manager, everything will be encrypted in a raw text. And then software like BlueSea. So BlueSea is basically used to interact with your GAT level interaction. So it comes in your Linux Ubuntu repository. And then your PyGAT is a combination of your GAT and your Python where you can create your own script or own GAT. And then your GAT attacker and your BTLE juice or your man-in-the-middle tool, where your laptop will act as a proxy between whatever the data that is being sent from your mobile phone and to your end device, where you can intercept a request, you can modify it, and then you can send it back, or you can understand the packets and then use BlueSea or PyGAT to again reverse engineer it. Focus much on your GAT and your GAP because that is where majority of the developers fails to implement a secure authentication or any kind of security measurement they fail to implement. Yeah, so GAT is more like your typical server and your client architecture, where assume your mobile phone is a server and then your end device is your client. So whenever a device wants to fetch a data, it will send a read request and then you get the data. Then device can also give a request and then your mobile phone will give a response. So in a GAT protocol, every kind of data is being sent in terms of attributes. So attributes basically consist of four items. So one is your 16-bit handle to identify what exactly, it's more like identifier. And similarly, they have a long UUIDs. So that is being defined by Bluetooth SIG and then the value. I mean, value is basically the data which you want to really transfer. And then fourth is your permission. So whether you want to write this value or read this value from. Yeah. So how it works is, so CAT has like 3 different categories. So one is your profiles. So profile is basically, with an example, profile is more like, let's say you have like multiple Bluetooth devices. So one is your heart rate monitor. So one is your, let's say, ECG or some other TENS device. So your heart rate will have a profile. So heart rate monitor is a profile that's been defined. So heart rate monitor will have services. Services basically like individual blocks inside your profile. So services, one service might be your basic device information, and then second device might be your real heart rate parameters, and then third might be your firmware update or different services based upon the device. So characteristics are individual data units. So in your first information services, the first could be the name of the device, second could be the version name, third could be your some other parameters. And similarly for HRM services, so you might have characteristics of like your getting the real heart rate or the location of your heart rate sensor or some other control parameters. Yeah. So best example, what I would say is, let's say your profile is more like a hard disk, then service are like your individual folders, and then your characteristics is your individual files, which are permission to read or write, where you can get your data or put your data back. Yeah. So now the problem with this is, so if you notice, I have mentioned UUIDs and 16-bit handle. The problem is, as I told you, all Bluetooth devices has to be interoperable. So if different vendors or different developers started to create their own custom UUID, so it becomes a little complicated for different apps to use a single devices. So a lot of companies started creating a group that is called as Bluetooth SIG. So they started standardizing these services and characteristics. So yeah, this is, let's say I have a heart rate monitor from a XY company. So I will have a specific set that is being defined by Bluetooth SIG. So Bluetooth SIG has defined a specific UID. So these are your Bluetooth SIG defined UUIDs. So this one corresponds to, let's say, 2A26. It means this one is a firmware version. And then the content is going to be a string. And then 2A19 is going to be a battery state. And then the data is going to be a percentage. It's like 8-bit. Yeah. So now this is also a problem if you consider security. Let's say I have a device, and again it's an heart rate monitor. So if a device is using a basic SIG, it becomes easy for me to know, okay, fine, this handle belongs to heart rate monitor. So now I can modify the things in the heart rate monitor and then I can send it. So there also a security concern arises. So to avoid that, developers have started using custom UUIDs. Let's say for heart rate, you don't really want to use a standard SIG attributes. You can still create your own UUIDs. Yeah, this 16, whatever the UUIDs, and then only your developer or your app knows what exactly this thing does. Also here, if you know strings or appearance or your normal percentage, it's also defined. Where if you have your own UUID, so you can define what exactly data you can send, and also only you know the format on how your data has to be sent. Yeah. So the basic step to access your GAT layer, yeah, I think I can show you that. So first step is always to check if your So it's always to check if you have a Bluetooth dongle. So I have connected a Bluetooth normal dongle. So let's assume this is my MAC address. So if you want to do a LE scan, I just have to do HCI tool LE scan, and that is going to display all the device. So today I'm going to show you I think I can show you yeah. So today what I'm going to hack into is a Bluetooth Widget Spinner. So this is basically a typical fidget spinner where you can use mobile application and a Bluetooth to send data. So in this case, I have programmed to show interlayer first. So this is molecular connected device. I don't really wanted to show a critical device to have. So I have chosen this fidget spinner where you can understand how you can write to it, how you can reverse engineer the entire Bluetooth app communication, and then how you can take over the device. Yeah, so now I know the MAC address of my fidget spinner. I'll just copy it. And I will use GAT tool. So I is basically interactive. -B is to put your MAC address. Just press enter. Then type connect. And then your color will change to blue. It means it's connected. So to look at all the primary services, the command is primary. So you can look at it. So this is your UID. So if you notice 1800, 1801, and then, yeah. So these are your Bluetooth SIG based services, whereas these are custom made UIDs. This is a list of the service that's being run. If you want to look at all the characteristics, the command is characteristics, enter. Yeah. So this lists all the characteristics. So if you look at the handle starts from 001 to 00B. So here you can assume it starts from 2 and then it ends till, yeah, till here. So this is one set of services that's being run in this. And then similarly for these two, this one is on one single services, and then this one handles 16. So till 16 belongs to the third service, and then the last 3 belongs to the last services. Now you can quit. This is so, yeah. So you can, there's a command called as read handles. So you can really read and write to those individual handles. Handles means basically the UIDs. So those files, to be precise. Yeah. So how do you really exploit it? Yeah. So right now we learned how you can really gain access into a Bluetooth GAT server. And then, but now the question arises is what exactly to send to the device. So now we need to find a way to what exactly the data is being sent to the device so that it's being controlled. So we need to understand the pattern. So let's say we reverse engineer the packet capture, or we use different tools to get those packets and then see if we can make sense out of it. And then we use the same GAT tool to interact with the device. Yeah, the easiest way is to use a BT snoof. So if you look at your Android devices has an inbuilt feature of logging all your Bluetooth communication. So if you go to your settings, developer option, there's something called a HCA snoof or BT snoof, where it captures everything in a Wireshark supported package, where you can individually see what are the commands that's been written. I can show you that. Yeah, this is one example which I have dumped it. So I'll just open it. I think it's a huge file. Yeah, no, I got it. So I think last one was my fidget spinner commands. Yeah. So if you look at your, yeah. So send write request. So some data is being sent to handle 0x0019, and then the data is this. So what you have to do is you have to look at individual data and then identify what exactly these are. Based on, say you have a smart bulb, then you want to control it. So you enable your HCA snoof and then change your color to a specific pattern. Let's say first fix it to red, and then fix it to blue, and then fix it to green. And then in the HCA jump, you can comparatively look for the patterns. Okay, so this one has this value, and then your second write request will have a different value. So based on this, you can identify the pattern, and then you can try to send the same data back. Yeah. So second tool is your GAT hacker. Trust me, this is an awesome tool if you want to pen test a BLE device. So basically, it's your man of the middle attack tool. So where your system will act as a proxy. So your system, you have to connect to USB Bluetooth dongles. So your one dongle will emulate as your device. So one dongle will emulate as your mobile phone. So your device will connect to your laptop, and also your laptop gets connected to your device. So whatever the Bluetooth GAT request you send to the laptop, it translates to your device, and then in the middle, you can look all the data inside it. Okay, I think I have a video for that. Yeah. Yeah. Basically, I am doing the same thing for the same fidget spinner. So the first step in the tool is to scan. So to scan for the basic advertisement packets. So we are using the scan to capture the advertisement packets into a file. So we got iChair Bluetooth fidget spinner. So now I need to copy all the service that's being run. Since I need to emulate the entire device, I need to have the services and also the advertisement packets to emulate, so that my mobile app will send the packets to the respective whatever the service is. Yeah. Third step is to start your proxy. Basically, in your proxy where it's node advertise, and then your advertisement file, and then your service file. So once you start that, yeah. So once it starts, you will get the screen. Yeah. So once I've connected my mobile phone, so I could see a lot of requests that's being sent. So my device has been connected and client connected. Yeah. So if you look at here, it's where you can see write request. So basically, I have enabled a write request as in I just turned on my fidget spinner and then turned it off, or vice versa. So this is basically the data that's being transmitted to the fidget spinner for it to understand the code and then turn it on. And this is the one to turn it off. Yeah. So you can now stop the process, or else if you want to have multiple device, you can do multiple operations like change the color. Yeah. So we know this is a UID in which it's been written. So if you compare it with the UID of the cat tool, where the handle is 0x0019. Yeah. So I can just copy it. Yeah, I think. Yeah. I'm just connecting to the fidget spinner. I'm just copying the same data. So the command is character write request, and then the handle, in this case 0x0019. It's the same handle which we saw in the, yeah. So you can see once it's written, the fidget spinner stopped. Yeah, so I have made this video since I can't use a camera and also a screen at the same time. So now I copy the second data and then I enter it. Now my fidget spinner starts. So you can do this similarly, you can reverse engineer it. Yeah. So similarly, for different devices, let's say a heart rate sensor. So what you can really do is you can get all the data, and then you can individually modify these packets. And then you know this is going to be a 65 or 75, and then you can modify it, then you can send it back. This is like an awesome tool. Yeah. Demo. Yeah, I think I have a demo where I reverse engineer the entire app. So this fidget spinner has an option where I can show images, show different patterns, turn on and off. Yeah, so the video is here. So I made a small Python script using the PyGat. It's basically a combination of all the scripts. I just created a long file. So it's basically the same character, right? And all the data that's being sent to display a, yeah, so it's, yeah. Yeah, so if you look at here, it's turned off, turned on. So I'm doing a different pattern. So it will spin in a pattern, and then it will even show up, yeah, Batman. So this I have done it by reverse engineering app, and then understanding how you can really send images, or how do you create from the device without having a mobile application. So the attack vector right now in this case is basically a fidget spinner. So let's assume you have a glucometer, smart glucometer, or some other devices where that is going to be super critical because that has a lot of issues. Yeah. These are the reference. I think I can share you the slides. Yeah. Yeah. And any questions? I'm back to questions. Yeah. How to create the custom profile? So it depends upon which platform you use. Let's say you're using Nordic, where they have given you an option where you can create your custom profile instead of using SIG. So basically the SIG UID is going to be, I think, around 128 or 128-bit, whereas your normal custom sig is basically your 6-byte. So based on that, you can create your own custom profiles. So what are the best recommendation for securing PLE devices against this? The problem is the Bluetooth 4.0, whatever the pairing mechanism has been broken like 3 years back. So the best recommendation, what I would suggest you use is make sure you have a sort of like authentication. Instead of using your default Bluetooth pairing mechanism, make sure you have sort of an encryption even in your data. So whatever the data that you are going to send in your individual characteristics, that you can encrypt it, or else you can use a sort of like a random generated public key. So where using that you can also encrypt it. And make sure don't stop with just connecting your device. Make sure you enable at least JustWorks or some other pairing mechanisms, because even having that is vulnerable, but without having a pairing mechanism, it becomes very simple for attackers to gain access to the device. So they can really connect to it. Right now, this device doesn't have a pairing. So I just used a typical GAT tool and then to access it, and then I can reverse engineer the packets, and then I can take over the device. So best practice is to at least have a pairing, or else you can implement some kind of a authentication mechanism in your app or the device where it will allow only a set of MAC address, or you pair it with the MAC address of your phone. So only those devices can really connect to it. And one more bad practice with the users is, let's say you have a smartwatch, and then people really don't connect to your mobile phone. At the end of the day, your mobile battery will be low. So people have a tendency to turn on the Bluetooth in your mobile phone. So your devices are left hanging. So your devices will start broadcasting for any attackers to connect to it, and then they can take over it. So if you want to save your power, make sure you turn off Bluetooth in both your device and also in your mobile phone, so that no one can really take control over it. So industrial, so can you provide some examples in industrial IoT where Bluetooth can be used? I think recently Bluetooth 4.0 supports mesh protocol. So instead of using your normal 6LoWPAN or some other, so maybe you can use your Bluetooth, and then you can create a mesh network. So from there you can, since it's super interoperable compared to other industrial protocols, so there you can really use it as a beacons or multiple wireless sensor nodes. Yeah, so other than pairing mechanism, are there any other major vulnerabilities in Bluetooth LE? So with respect to device perspective, I think the most primary vulnerability is in the pairing mechanism. But if you look at your basic Bluetooth stack, so if you look at let's say your Android phone or your any Windows, not Windows, yeah, I think Windows and Linux. So everyone uses a stack from your BlueZ. So there, I think recently there has been an attack on Bluetooth called as Blueborn. So where they have done a heap exploitation. It's more like a buffer overflow, where you can send a random chunk of data that is going to trigger a buffer, and then from there you can execute multiple commands. So a company have found a vulnerability in that, and then they have written an exploit around it, where just by knowing your MAC address, I can really take your entire device or run any script in your laptop or your phone, and then I can gain control over it. Yeah. So which Bluetooth device I can hack at home and put hands on to hack it. So the basic tool is, so if you want to really get into Bluetooth, I think setting up your pen testing lab is going to be super easy. So because so for you to really hack into your normal GAT, you just need a normal Bluetooth dongle that costs you like around what maximum $3 to $4, and then you can use any commercial devices. So you can start with a normal baggage tracker. Baggage tracker doesn't have any pairing mechanisms, so they just connect to any device it can broadcast. Or else you can get a Bluetooth-based smart bulbs, or you can get those cheap Chinese smart locks. Or I think there are a lot of medical devices like your smart thermometer, your smart glucometer, where you can try to use multiple tools like GATTaker or PTLE Juice, and then you can try to start with hacking those devices. Yeah. So Bluetooth mesh versus Wi-Fi mesh. So Wi-Fi mesh, basically, if you look at mesh, is basically a sort of like a algorithm or a protocol. So whereas both is I'm not sure how you can really relate a Bluetooth mesh to a Wi-Fi mesh, because Bluetooth works in its own specifications, where Wi-Fi works in a complete different specifications. So I'm not sure how exactly you can relate a Bluetooth mesh and a Wi-Fi mesh with respect to the security perspective. Even if you look at Wi-Fi, I think recently the attack by crack, where you can really connect to a device by hacking into the WPA2. Yeah. So what is Bluetooth, blue bugging, blue snaffing, and blue chat? So these attack works predominantly in your Bluetooth Classic. So this case, they work where you have your HCI or your RF com communications. So this device, you can try it in your headphones. So in your L2 cap, an option where you can really ping to L2 cap. If you ping a L2 cap in a very short duration, your L2 cap will crash. So your entire, whatever the Bluetooth stack is going to crash. So these attacks are basically the same. So one will send you, there are a lot of framework like PWN Tooth, Blue Diving, where they send like your random files, random OBX push files, and then they try to see if they can crash the L2 cap. Bluetooth 4.0 is available to use in market. Yeah, it's available. So BLE has been there in the market for the past around 4 to 5, more than like 5 years. So right now people are coming up with 4.0 and even 5.0. So even if you look at the 5.0 stack, so even they use the same pairing mechanism that you use in the 4.0 and 4.2. So whatever vulnerability you find in the 4.0 or 2, you might obviously find it in the same 5.0. Yeah, thank you so much. Thank you so much for all listening to my talk. So if you want to just reach me, you can always drop an email. So I'm just putting my email here, and then you can always follow me on Twitter. Thank you once again.